So we will do an example of a transformation. So let's say you are flying in the Millennium Falcon and you can see the Death Star. So then you do a maneuver to transform your ship. So you're flying to a new location and you rotate. Then you want to see what is now the coordinates of the Death Star in your new frame. So for this, we will need to find the transformation that relates frame 1 to frame 0 and the point in the new frame. So procedure here. First, we need to use theta to find r of frame 1 with respect to frame 0. So then once we know r, we can find t10 equals r10 010 0001. So that'll get us this transformation. But to get the new point, we recall that P is going to P1 has to equal T01 P0. So we need to get T01. So first we get the inverse of R. So R01 equals R10 transpose. And then we can get the inverse transformation. So T01 equals R10 transpose 0 negative R10 transpose times O10 1. And then finally, P1 equals T01 P0. So we'll go through each of those. But first we need to be given some values. So let's say O01 equals 7, 2, 0. P0 equals 1, 4, 0. And theta equals 40 degrees. Start with step 1. So theta goes to R10. Well, we actually found this from before. R10 equals cosine, sine, minus sine. Cosine 0, 0, 0, 0, 1. We put 40 degrees in for all of those. And then we get the same rotation matrix before, 0 0.94, 0 0.94, 1, 0, 0, 0, 0, and 0 0.34, negative 0.34. Now for the transformation, we just plug in this r and that origin into t. So T10 equals r, so 0 0.94, 0 0.34, 0, negative 0.34, 0 0.94, 0, 0, 0, 1. We got that rotation. Then we need to put in this 0, which is actually 3 zeros. And then finally, we put in that origin, which was from here, 7, 2, 0. And the last element is a 1. So we found T10. Now to get P1, we'll actually have to take the inverse of this and then multiply that by the original point. So to get the inverse rotation matrix, we ended up just doing the transpose. So the only thing that changed was pretty much the signs on these two. But to get the last column for the transformation, we'll need to do negative R 10 transpose times O 10. So if we actually multiply these out, 0.94, 0.94, 1, negative 0.34, 0, 0, 0.34, 0, 0. This is the trickiest part. And then multiply that by the origin, 7, 2, 0, 1. So that equals negative 7.26, 0.5101. Okay, so this is what goes right here in this spot. So then to get this, we have T 0, 1 equals T10 inverse, which equals that rotation inverse, which is the same as this one, 0.94, negative 0.34, 0, 0.34, 0.94, 0, 0, 0, 1. So we got that part, then the zeros along the bottom, 0, 0, 0. Then this part, which would be negative that, and up times that, which is negative 7.26, 0.51, 0, and then finally 1. So we got the inverse transformation. Now finally, P1 equals T01 times P0, which equals all that times P0, which is 1, 4, 0. But then remember, we have to augment it with 1 because it's a point. So we do this multiplication and we get negative 4.95, 3.93, 0, 1. Okay, now this 1 right here doesn't really mean anything, but we can kind of do a reality check on the final point. So the final point is negative 4.95 in the x. So if we look at that, let's go here. It's negative in the x. Okay, that makes sense. Plus 3.93 in the y. Okay, so we go plus in the y. So that makes sense. And then 0 in the z, which is good because there were no z components. And then the 1, which we can just ignore because the 1 just means that it's a point. So here is negative 4.95 in the new x and 3.93 in the new y. So this is the new Death Star coordinates. As compared to the original coordinates, which we had here was 1, 4, and 0. So 1 in the x and 4 in the y. And then the origin of frame 0 with respect to frame 1, we can see is 7 in the x and 2 in the y. So final point coordinates, P1 equals negative 4.95 in the x, 3.93 in the y, 0 in the z.